Hi everyone, welcome to another interesting video of Intro to Machine Learning. This is lecture 17. In this video, I'm going to talk about k-nearest neighbors, which is a very simple machine learning algorithm. So in fact, we have looked at more complex algorithms before. This is going to be fairly simple and easy to understand. We'll talk about the mathematical interpretation and obviously a Python implementation of KNN. So this is in short also known as KNN. Whenever you see that in machine learning terminology, you should know that we are talking about the k-nearest neighbors. Okay, so what is this algorithm? This algorithm, the KNN algorithm, assumes that similar things exist in close proximity. So what does that mean? Let's look at our example that we've been looking at ever since we started working on classification problems. So I have age and salary of individuals, and I have the outcome as people bought something or they did not buy anything. So purchased and not purchased. Let's say the data is distributed something like this. So I'm just making this up. This is not the real data. I will provide you the actual code, and I've provided the data before. So let's say this is how the data looks like, and I have a new point, which obviously I need to classify. Let's say that new point lies somewhere here. Right, so this is my new point. I need to classify whether this is going to be purchased or not purchased. Now, according to the k-nearest neighbor algorithm, the distance between this new point and the ones that are in close proximity with this point is important. So we assume an input parameter k. K is an integer, it's a number. Let's say if k was 5, I'm going to calculate the distance of this new point, the Euclidean distance, and I'll show you how that's calculated. Euclidean distance, I'm sure you're familiar with that. Euclidean distance of this point with each of its neighbors. So let's say I'll calculate with this, and so on, whatever points are in close proximity, and I'm going to sort them and find the top 5. The ones that are closest. So let's say I found that these are in the top 5, these 5 points are in the top 5, and then I'll do a voting and see out of these top 5 points, the majority vote goes to purchase. So this should be classified as purchased. This is a very simple idea, and this is how this algorithm works. A little bit more about the algorithm. So I just talked about the distance. This is how the Euclidean distance is calculated. But there are other distance functions that are also available for k-nearest neighbor algorithm. Sometimes we calculate the Manhattan distance. Usually the default when we are using scikit-learn is a Minkowski, right? So this is the default. And here you can tell that if I have appropriate values for q, if q is 2, then again this is going to reduce to the Euclidean. Right, so this is a more general form of Euclidean rather. Okay, so a case, as we said, is classified by a majority vote of its neighbors. We just saw that, right? And there are ways to break ties sometimes, so then there are certain rules that apply. It should also be noted that all these distances are valid for continuous variables, right? In the instance of categorical variables, something known as a Hamming distance is used. Right, so let's say these x and y's were zeros and ones, then there is another distance that's used to calculate the distance. But the idea remains the same. We are trying to find the close proximity. Okay, and so when we are dealing with categorical variables, always remember standardization is important in those variables, because we have to translate them and find the numerical representation of those. Right, so that's a very simple thing to remember, but remember, we have to take care of standardization. Okay, now what is this k, right? We said k is an input parameter, but there are ways to choose a good value of k, right? So to select k that's right for your data, maybe you can run the KNN algorithm several times and see which k value reduces the error the most, and then maybe choose that k. That could be one way. Now think about k equal to 1. Right, if this was like, let's say this was this is one category of things, and this is this, and there is this point, right? Let's say data was distributed something like this, and I come up with a new point somewhere here, right? So the new point lies largely with this x category, right? But there is the closest proximity is with this point, and if I have k equals 1, this new point will be misclassified, right? So k equals 1 makes the predictions less stable, as you can see. So we have to increase the value of k. And as we increase the value of k, our predictions become more stable. And because we are doing that majority voting or averaging, so it's more likely that we get accurate predictions up to a certain point. And again, this has to do with the efficiency. If you keep on increasing k, then you'll see that there is an optimal point beyond which you will start getting more errors. So based on running it multiple times and then determining k is the right way of doing it, and definitely k shouldn't be extremely small, and you can begin with a good value k equals 5 and then see from there. Okay, so this was about choosing k. Then finally, a little bit about the algorithm. So there are advantages. As you can see, it's simple and easy to implement, and I would say interpret as well. It's really easy to understand how it's working as long as you have the idea of distances and close proximity. It can be used for classification and regression. We are using it for classification problem, the same salary and age problem, and checking whether the person bought something or not. And one of the disadvantages is that the algorithm gets significantly slower when the number of predictors is high. And you can tell why, because the Euclidean distance becomes tedious to calculate in higher dimensions, right? So that's why it becomes really slow. Okay, so this was about the k nearest neighbors. Let's look at the implementation. I'm going to keep this and go here into Spider. Now, the rest of the stuff stays the same. I'm not plotting anything, so let me just comment that. Okay, so here I'm importing the same data set again. This is the data set that we've used multiple times before. Let me show you. Age and estimated salary is given. We have to predict whether the person purchased something or not based on these two variables, right? And here I import the data set, create the x and y's, and split into test training set. That we like, all of this has been done before. I'm not going into a ton of detail because I've had videos specifically focusing on each of these parts. So we've done that. The important part is the training section where we train with the KNN. So I'm importing from this module, scikit-learn.neighbors, I'm importing this class KNeighbors classifier. How did I find it? As I've told you before, just go to your Google search or any search that you use, just type k nearest neighbor scikit-learn, and that'll take you to this page. Here it has a ton of detail about this class, which is the KNeighbors classifier, right? Some of the parameters, the input parameters, n neighbors is my k, the default is 5. You can change it, but that's the default for this, right? And then there are other parameters. The one that I'd like you to focus, or let me say, like a little bit know more about, is the metric. So here you can specify which distance you want to have, right? The default is Minkowski, which is nothing but the Euclidean distance, because they use by default p equals 2. So imagine they are using Euclidean, but you can go to this link, distance metric, and check for different values of this metric parameter. But by default, it is the Euclidean distance, right? And then there are other parameters. So we are just focusing on these basic ones, and neighbors is 5, and then the metric is Minkowski. When you're using Minkowski, P, which was in our slides Q, right, is 2, right? So here it was Q, let's say this is P equals 2 is Euclidean. So that's exactly what we're doing here. And let's actually run this. And I think I remember we have tested it for some previous values, so we can test it here as well. What happens to a person whose age is 35 and whose salary is 100K, right? Whether that person is going to buy this or not. So let's test for that one case, and then we are going to see the confusion matrix and all of that, right? So according to k nearest neighbors, yes, the person is going to purchase, and I think we've got majority of the algorithms saying yes, the person is going to purchase, except for one, which I don't remember which one, but yes. Now here, let's predict for each of the test cases and then see the accuracy, because then we can compare it with other algorithms that we've used. If you remember, the logistic regression gave us the accuracy of 0.89. So let's see what k nearest neighbor does in this case. So here we get an accuracy of 93%. And if you look at the confusion matrix, which is this, right, only 4 plus 3 are misclassified, which is really, really good, right? So these are the wrong predictions. Just 7 of them are wrong predictions, and the rest of them are correct predictions, which is a huge, huge advantage with this one. For this particular data set, if I remember it correctly, k nearest neighbors has given us the highest accuracy. Okay, so this was about it. This was about k nearest neighbors, and I'll end the video here. Thanks for watching.